Jupiter, the colossal gas giant of our solar system, has long fascinated scientists and dreamers alike. Its swirling storms, mysterious magnetic field, and iconic Great Red Spot have teased the imaginations of astronomers for centuries. In 2011, NASA launched the Juno spacecraft on a daring mission to unlock the secrets hidden within this planetary giant. What Juno would discover during its intricate orbits around Jupiter would redefine humanity's understanding of the largest planet in our solar system. From the moment it approached Jupiter in 2016, Juno's suite of instruments began to peel back layers of mystery. The spacecraft, designed to withstand intense radiation, sent back images of clouds unlike anything seen before. Each orbit revealed intricate details about the planet's composition, atmosphere, and magnetosphere. Scientists eagerly awaited the stories hidden in the torrents of information flowing from the spacecraft. The journey to Jupiter spanned nearly 5 years across the vast emptiness of space. Juno traveled over 1.7 billion miles, guided by precise calculations to ensure a perfect arrival. On July 4, 2016, it successfully entered Jupiter's orbit, marking a historic moment for planetary exploration. Juno's instruments immediately began collecting unprecedented data on Jupiter's atmosphere and magnetosphere. Its microwave radiometer probed deep into the planet's cloud layers, while JunoCam captured detailed images of swirling polar cyclones. These observations challenged pre-existing models of gas giant dynamics. Gravity science experiments mapped the interior mass distribution, hinting at a core that was partially dispersed rather than compact. Juno's elliptical polar orbit allowed it to gather critical data while minimizing radiation exposure. These findings reshaped theories of planetary formation. Juno revealed the extreme nature of Jupiter's auroras, with particles accelerated to near-light speeds. The spacecraft's measurements showed the planet's magnetic field was far more complex and dynamic than imagined. Each pass deepened the mystery surrounding the magnetosphere. Closed passes over the Great Red Spot provided breathtaking images and measurements. The storm's depth extended hundreds of kilometers, far beyond earlier estimates. Winds near the core were stronger and more turbulent than predicted. In its early months, Juno painted Jupiter as a planet of contrasts, with intense radiation belts surrounding serene cloud layers. Giant cyclones danced alongside calm equatorial zones, revealing internal heat dynamics. Each orbit offered new surprises, keeping researchers on edge. As Juno continued its orbits, it began to reveal the hidden layers of Jupiter's atmosphere. The microwave radiometer penetrated hundreds of kilometers beneath the cloud tops, uncovering turbulent ammonia flows. These observations showed the planet's atmosphere was far more complex than previously imagined. Juno's data revealed a banded structure in the clouds that extended deep into the planet's interior. Storms were not only surface phenomena but connected to powerful internal heat currents. This challenged previous assumptions that Jupiter's bands were shallow features. The spacecraft also detected lightning strikes far larger than those on Earth, illuminating hidden storms. These flashes revealed energy dynamics driven by deep atmospheric processes. Scientists began to understand the scale and intensity of Jupiter's weather systems. Gravity measurements suggested that the planet's core might be fuzzy rather than solid. This diluted core appeared to mix with surrounding hydrogen and helium layers. Such a discovery offered clues about how Jupiter formed in the early solar system. Juno's close flybys of the poles uncovered massive cyclones arranged in persistent geometric patterns. Some were larger than Earth, rotating in tight, stable formations. These observations revealed a dynamic stability that had never been seen before on any planet. Each orbit added more details to Jupiter's magnetic field map. The spacecraft detected unusual variations in field strength, linked to deep flows of charged particles. These discoveries hinted at connections between the planet's interior and its violent auroras. Juno's journey over Jupiter's poles revealed a planet of perpetual motion and turbulent energy. Massive cyclones, some larger than Earth itself, swirled in tightly packed formations at both poles. These storms persisted in geometric patterns that defied previous models of atmospheric dynamics. High-speed winds twisted around the storm centers, revealing complex rotational behaviors. Scientists were captivated by the sheer scale and stability of these polar phenomena. Beneath the cloud tops, Juno's instruments detected intricate ammonia flows shaping storm activity. Deep convective currents fueled the violent weather patterns observed on the surface. Some storm systems extended hundreds of kilometers downward, linking atmospheric layers with the interior. This connection suggested that Jupiter's weather was powered not just by solar energy but by internal heat. Each orbit peeled back new layers of understanding about these enormous storms. The spacecraft also mapped Jupiter's intense radiation belts with unprecedented precision. Streams of charged particles circled the planet, accelerated by its powerful magnetic field. These belts were far more variable than scientists had predicted, shifting with storm activity. Juno's magnetometer recorded these fluctuations, revealing a dynamic and restless magnetosphere. Understanding this radiation environment was crucial for the safety of future missions. Juno's close passes over the Great Red Spot provided groundbreaking insights. The storm's depth, far beyond initial estimates, demonstrated the scale of Jupiter's internal energy. Winds inside the vortex reached speeds unmatched anywhere else in the solar system. Chemical analysis of the clouds showed exotic compounds, hinting at unknown atmospheric reactions. These observations forced a reevaluation of the storm's longevity and evolution. The spacecraft also discovered smaller storms surrounding the poles, interacting in chaotic yet stable patterns. Some merged or split over time, creating a constantly shifting atmospheric tapestry. These interactions illuminated the mechanisms that sustained Jupiter's weather for centuries. Scientists were able to model how energy transferred between storm systems. Every detail painted a picture of a planet alive with movement. Juno's instruments revealed the coupling between Jupiter's magnetic field and its auroras. Electrons and ions funneled along magnetic lines, colliding with the upper atmosphere in brilliant displays. These auroral storms were powered by the planet's rotation and deep internal processes. Observations suggested that the magnetic environment influenced atmospheric circulation. Each discovery highlighted the profound interconnection of Jupiter's systems. As Juno completed its initial polar passes, the spacecraft had transformed our understanding of the gas giant. Jupiter was no longer a static, banded sphere but a planet of intricate layers and ceaseless motion. Storms, magnetic phenomena, and polar cyclones painted a portrait of chaotic beauty. Researchers began piecing together how internal heat, rotation, and magnetism sculpted the planet's atmosphere. The revelations from these early orbits hinted at even deeper mysteries waiting to be uncovered. Juno's gravity measurements revealed surprises about Jupiter's internal structure. The planet's core appeared diffuse, not a compact solid mass as previously theorized. This fuzzy core suggested heavy elements mixed with hydrogen and helium, challenging classic formation models. Such a structure hinted at turbulent early history during Jupiter's birth. Scientists realized that understanding this core was key to unraveling solar system evolution. Deep atmospheric flows also revealed unexpected dynamics beneath the cloud layers. Juno detected jet streams penetrating far deeper than anticipated, influencing storm patterns above. These currents carried heat and material between layers, powering the planet's complex weather systems. The link between internal motion and surface phenomena became increasingly clear. Each orbit offered new insights into Jupiter's hidden interior. Juno's magnetometer uncovered surprising anomalies in the magnetic field. Localized regions of extreme intensity suggested internal structures that had never been imagined. Some magnetic features were offset from the planet's rotation axis, creating unexpected auroral effects. These anomalies hinted at uneven flows of conducting material deep within. Scientists began to reconsider models of planetary dynamos in giant gas planets. The spacecraft also revealed that polar cyclones were anchored by deep atmospheric roots. These massive storms maintained their positions through interactions with Jupiter's internal heat and rotation. Juno's data showed that cyclones at the poles were remarkably stable over time. Surrounding smaller storms were influenced by these dominant vortices. The polar regions became a laboratory for understanding planetary stability. Juno's microwave measurements penetrated thick cloud layers, mapping ammonia distribution with unprecedented resolution. These patterns highlighted strong latitudinal differences, connecting chemical composition with atmospheric circulation. Some regions exhibited unusually high concentrations, indicating deep convection and mixing. This revealed how Jupiter transports material from interior to upper atmosphere. Each discovery reshaped the understanding of gas giant chemistry. Radiation belts posed both a challenge and a source of discovery. Juno's instruments measured particle fluxes in unprecedented detail, revealing dynamic changes tied to auroral activity. These interactions showed how Jupiter's magnetic field channels energy throughout the planet. Understanding this environment was crucial for interpreting other spacecraft data. The radiation belts became both a window and a hazard for exploration. As Juno's mission progressed, the gas giant emerged as a planet of contrasts and complexity. Internal dynamics, magnetic anomalies, and polar storms painted a picture of constant motion. Jupiter was revealed not as a uniform sphere, but a living, breathing world. Each orbit deepened the understanding of its inner workings. The discoveries hinted at even more mysteries yet to be revealed. Juno's mission has transformed humanity's understanding of Jupiter, revealing a world of immense complexity. From deep internal flows to towering polar cyclones, every orbit uncovered phenomena previously unimaginable. The spacecraft's instruments captured data that challenged decades of planetary theory. Scientists now view Jupiter not as a simple gas giant, but as a dynamic, interconnected system. Each revelation deepened the mystery and wonder of the king of planets. The gas giant's magnetic field emerged as one of the most intricate in the solar system. Juno's measurements exposed unexpected anomalies, shaping the auroras and influencing atmospheric circulation. These findings reshaped models of planetary magnetism. Understanding Jupiter's magnetic behavior offers insight into other planets and even exoplanets. The connection between interior dynamics and surface phenomena became unmistakably clear. Jupiter's storms and cyclones continue to astonish scientists with their power and stability. Polar cyclones, some larger than Earth, rotate in precise, enduring patterns. Deeper flows revealed by microwave data explain the energy driving these storms. Even the Great Red Spot, long thought to be stable, showed complexities that challenged previous assumptions. Juno's observations forced a reevaluation of what defines planetary weather systems. Ammonia and chemical distributions provided clues about Jupiter's interior composition. Patterns observed in the atmosphere reflected deep convection and mixing processes. These insights suggested that the planet's formation history was far more turbulent than previously believed. Heavy elements within the diffuse core hint at early collisions or accretion events. Each orbit allowed scientists to piece together the planet's intricate story. Juno's close encounters also revealed the intensity and reach of Jupiter's radiation belts. Particles accelerated by the planet's magnetic field created a hostile environment for spacecraft. Yet, these measurements offered crucial insight into the behavior of charged particles and auroral interactions. Understanding this radiation is key for future missions, both to Jupiter and beyond. Juno's endurance in this environment stands as a testament to human engineering. As the mission progressed, The spacecraft's images and data captivated the public worldwide. The swirling clouds, violent storms, and glowing auroras inspired awe and wonder. Juno transformed Jupiter from a distant dot in the sky to a tangible, dynamic world. Its discoveries have reshaped textbooks and planetary science alike. Humanity gained a new appreciation for the complexity of gas giants and the forces that shape them. Juno's legacy will endure long after the mission ends. Its detailed exploration has revealed Jupiter as a living planet, full of motion, mystery, and majesty. The spacecraft's findings will inform future missions, from robotic probes to human exploration of the outer solar system. Scientists now understand that even the largest planets are intricate and alive with unseen forces. Juno's journey has expanded the horizon of human knowledge, leaving a permanent mark on the story of planetary exploration.